In the first two vision lectures, we focus on the eye, the retina, the elements of the primary visual pathway. We noticed that with three different pathways that were at least partially dissociated in the primary visual pathway. Now we're going to turn our attention to where two of those pathways become separate completely. So we're going to look at the ventral and dorsal pathways. The ventral pathway is often referred to as the what pathway, and we'll talk about its functions and dysfunctions. That is what happens when that pathway gets damaged. And then we'll look at the dorsal, which is sometimes called the where or how pathway, its functions and dysfunctions. That is what dysfunctions occur when it gets damaged, and we'll focus on optic ataxia. Later, we'll turn our attention to the retinotectal pathway. We'll talk about its anatomic elements and its overall functions. So once we get to the visual cortex, once we see the visual pathway getting to V1, then it starts to actually change into two separate pathways that are really pretty strongly dissociated. One pathway is nicknamed the what system, and it runs ventrally to region TE in the inferior temporal lobe. The what pathway processes color, fine texture, shape, and fine depth information. The what pathway contains projections primarily from parvocellular layers of the LGN and has many cells that are sensitive to the types of shapes and colors and large numbers of cells with receptors in the fovea. So remember that the parvocellular pathway, that pathway was composed predominantly of cells from the fovea. Now, as that pathway moves towards area IT, at the very bottom of the inferior temporal lobe here, the cells start to lose their retinotopic mapping structure. They stop mimicking the structure of the retina, which mimics the structure of the visual environment. Now, this sort of famous wise tale that Munchkin et al. In 1983 published a classic study. Now, people widely but quite incorrectly cite this as identifying the dorsal and ventral pathways and determining their respective functions. While they did do this, and it was published and it did become sort of famous, these pathways were known to be separate. And in fact, in evolutionary biology, comparative evolutionary biology, those evolutionary biologists, many of them actually Russians, all the way back in the 1920s, had distinguished between these two pathways and looked at their evolutionary development in vertebrates. So this is sort of true, but it's really not. What happens then after we lesion chemically or surgically in the temporal lobe area? Well, monkeys become severely impaired in their ability to discriminate among shapes and fine patterns. But they're relatively unimpaired in their ability to discriminate locations. So, for instance, lesion monkeys have difficulties with object recognition tasks, but not with landmark discrimination tasks. So, what they're looking at, textures, colors, shapes, that seems to be impaired. Where they're looking at, that does not. Now, I've got a movie, it's a pretty old movie, that shows what happens when we have damage to this pathway, the what pathway. What we get is visual form agnosia. People with visual form agnosia have difficulty perceiving objects, shapes, and orientations. Now, if the subject has difficulty perceiving the shapes, then it's called aperceptive agnosia, and it's associated with damage to the posterior inferior temporal lobe. If the subject cannot identify the objects. Clinicians call that associative agnosia, and it generally results from damage to the anterior areas of the inferior temporal lobe. So I'm going to insert a movie here. Keep in mind, this is a pretty old movie. Its quality isn't fantastic, but it does illustrate visual form agnosia.
Let me give you a hint.
Okay.
I'm going to give you a choice, and you tell me what this is.
Okay, I can tell you then.
Okay. Is this a clock, a lock, or a telephone?
A lock.
Is it a lock?
A clock, a lock, or a telephone? Okay, let's rule out. Let's rule out a telephone. A clock or a lock? Clock. That'd be a lock. Must be a lock then.
Are you sure?
No, I'm not. But I don't recognize it as a telephone.
Mm-hmm. Do you recognize it as a lock?
No, honestly, I don't. But it's just it really looks very indescript to me.
Uh-huh. But your hands know what they want to do.
I know, and they want to do something.
That's right.
I can see them.
Uh-huh.
Yeah, I can just picture them, and I know that I have. It's like I'm undoing a combination lock.
Good.
Huh.
Okay, good. We had to work on that one, didn't we?
No shit.
That's okay.
What is this I'm holding up in front of you now, Caroline?
God. It's a man's piece of jewelry or watch or something, but I can't distinguish which one it may be.
Would you take it in your hand? Just take it in your hand.
That's the worst thing. It's your tie.
You having trouble finding it?
I found the tie.
You found...
Your tie.
You found my tie. She says she found my tie, but what is it I'm moving in my hand? I'll get it in the right field here so that she can be sure to see it. Do you see something moving now?
Yes. I don't know what it is. It looks like a round circle.
Looks like a round circle. Take it in your hand.
Something that's connected to this, whatever it may be.
It has hold of my wire here. Caroline, I'm going to put it in your hand and you tell me what it is. What is it now?
A watch?
So, is it a watch? Is it? Just feel of it some more.
Oh, it's my glasses.
Good for you. What is that I'm holding up in front of you? Well, she certainly is having trouble recognizing it.
I'll say a lamp. I don't know.
Touch it now.
Must be a lamp.
She had trouble finding it. Now what is it now that it's in your hand?
Keys.
Keys.